satellites are of several types. Geostationary satellite is there, polar satellites are there. Okay, so we will see them one by one. First of all, how to project a satellite? To project a satellite, first of all, we must impart escape velocity to the satellite. Escape velocity for Earth is what? Escape velocity for Earth is, yes, Hemant, answer. What is escape velocity for Earth?
11.2.
11.2 kilometers per second. Per second. In 1 second, it must cover 11 kilometers. If it is covering that much kilometers in 1 second, then it will leave the Earth's orbit, or we can say Earth's gravitational field. Now, right now, here natural satellites are natural and they have a particular time period. Natural satellites are already there in nature, like Earth's natural satellite is Moon. The Moon is naturally orbiting Earth because of its gravity. Here we are studying about artificial satellites. So write down principle of launching satellite. What is the principle of launching a satellite? Whenever we are wanting to launch a satellite, we do not just want to give it escape velocity. We do not want the satellite just to leave the Earth's gravitational field. We want it to rotate around the Earth. We want it to perform revolutions around the Earth in particular orbits. Is it not? So, we need to give it two kind of velocities. First, we must take it up to a height h. Okay, up to its altitude, required altitude at what we want it. And after that, we must give it an horizontal velocity so that it can continue circular motion. Okay. So, put a satellite into an orbit. We need to give two velocities. First one, a minimum vertical velocity. Take the satellite to suitable height. Second, after the satellite has ascended the required height, it is given a horizontal velocity. Make it move in circular orbit around the Earth. Write it down. Done. Now next is orbital velocity. Okay, see, this is Earth. This is Earth. Now, imagine this is our orbit of satellite. Okay, this is our satellite which is performing revolutions. Now, how much velocity this satellite must have in its orbit? This is the center of Earth. And this is the satellite, okay? This is till this point it is radius and it is the height of satellite. So total height is what? R plus h. Total distance from the center of Earth for satellite is R plus h. R plus h. Satellite must have some velocity v or v naught in this direction, tangential. It must have some small mass m, and this is Earth. Its mass must be capital M. The mass of Earth must be capital. Now, mass of Earth is known to us. Height of the satellite or distance of the satellite from the center of Earth is also known to us. The satellite is performing revolutions.
ఏమేమి ఉంటాయి కూడా ఇచ్చారు చూడు ఇంగ్రీడియంట్స్ కూడా ఇచ్చారు చూడు
In this
అన్ని
direction.
అసలు అవుతున్నాయి
Okay. Right. Okay. Orbital velocity. Let capital M is mass of Earth. Capital R, radius of Earth. Small m, mass of satellite.
ఇది పెట్టు
V naught. Orbital velocity of satellite.
అన్నిట్లో ఏదైనా పెట్టు చెప్పు ఏది పెట్టు
Height of satellite above Earth. Orbital radius of satellite. Okay. Now we will apply the concept of circular motion. Whenever anything is performing revolution, there must be a centripetal force and there must be a centrifugal force.
180 అంటే
Centrifugal
ఇటు
force
చూసాం
will be
ఎక్కడ
this one, in this opposite direction. This is centrifugal force, and centripetal force will be in this direction. This is the centripetal force. Centripetal force will be force of gravity, and centrifugal force will be pseudo force in opposite direction. For any body performing circular motion, centrifugal force is equals to centripetal force. Centripetal force is attractive. Here centripetal force is force due to gravity, and centrifugal force will be mv square by r plus h. What is this v? This v here is orbital velocity. This is v naught. Okay. So what we are getting, m v naught square on r plus h. This is equal to under root of, not under root of, g m1 m2 upon r square, r plus h. This r plus h square and square will cancel out. This m will cancel out. Orbital velocity v naught will be what? From here what we are getting? Orbital velocity is equal to gm upon r plus h. This we are getting. This is our orbital velocity. And one thing we know. What do we know? Small g is gm upon capital R square. It means what is gm? Gm is small g into r square. So what we can write? We can write v naught equal to under root of gm is g r square upon r plus h. Okay, now r square is there, take this r outside. R under root of g upon r plus h. This is the orbital velocity.
तो स्क्रीन थोड़ी छोटी करना।
हेमंत, are you getting it? अंशुल समझ में आ रहा है? अंशुल समझ में आया? हेमंत, am I audible? Are you getting this? Hemant, you are not audible.
మనకి ఆఫర్ ఇచ్చాడు స్విగ్గీ ఇన్స్టామార్ట్లో. 200 గ్రాముల సరుకులు కొనుక్కుంటే అవసరమే ఏంటి కేజీ రైస్ ఫ్రీ చేస్తాండ బాస్మతి. ఆర్డర్ పెట్టామన్నా ఏం కావాల్సి చూసుకో. కేజీ బియ్యం ఫ్రీగా వచ్చినాయి. చూపి సిస్టమ్
ఇదే వస్తుంది.
ఫస్ట్ రోజు కదా
लिख करके बताना भाई।
लिख लिया सर।
हेमंत taken down? Now let us move.
ఏమైంది?
अच्छा देखो यहाँ तक अपन ने देखा वेलोसिटी ऑर्बिटल वेलोसिटी इज r अंडर रूट g बाय r प्लस h. This is orbital velocity. If satellite is very close to Earth, it means what? It means h is very smaller than r. Then we will neglect h. And in that case, V naught is R under root G upon R plus neglect H, it will become 0. It will become under root of this R will come inside, it will become under root of GR. This is the orbital velocity. This is the orbital velocity. And G is known to us, R is also known to us. Both are known to us. Therefore, an estimate of orbital velocity we can get from meter per second square. R is of 6.4 into 10 raised to 6 meters. Therefore, V naught equals to what? Under root of 9.8 into 10 raised to 6. Equal to 7.92 into 10 raised to 3 meter per second. Or we can write 7.92 kilometers per second. This must be the velocity of a satellite to perform revolution. Like if we are projecting a satellite above 10 kilometers above Earth's surface or 20 or 50 kilometers above Earth's surface. Just 50 kilometers. And radius of Earth is 6400 and 2030 in front of 64 is very less. Okay, even 6400s, even if we take it to 64 kilometer, then it will be what? Even if we take it to 64 kilometers, even then it will be just 1%, 0.01. It is coming out 64 upon 6400. So it will become just 1% of the radius of Earth. And diameter of Earth is very large in front of it. Satellite can absolutely revolve in that distance, at that height. Okay. So orbital velocity of satellite, from here what we are getting? What can we see from here? From here we can infer that Orbital velocity of satellite is independent of the mass of satellite. Whatever the mass of satellite, either it is a satellite or it is a space station, their velocity must be 7.92 kilometers per second. Only then it will be able to revolve in that orbit around Earth. Right now. The orbital velocity of satellite just first is independent of the mass of satellite. Second, decreases with increase in the radius of orbit. Means if height is increasing, orbital velocity will decrease. Third, depends on mass and radius of the planet. Mass and radius of the planet. Okay. Take it down. I'm just coming in a minute. हेलो, यस डन, कंसोल हो गया, आगे बढ़ेंगे।
हाँ सर।
नाउ राइट डाउन दिस क्वेश्चन.
రైట్ సైడ్ పెయిన్ వస్తుందంటే అది మామూలుగా వస్తూ ఉంటుంది దాని గురించి మళ్ళీ అవసరం లేదు కాలికి ఏం చెప్తానంటే చూసింది బాగా రుద్దుకుంటుంది సోప్ అని వేసి ఏం జెప్స్ అని లేకుండా ఏం కాదు అదేం చేస్తారని దానికి చెప్పింది
half of its present distance from the sun. How many days will be in 1 year? How many days will be in 1 year?
ఏం లేదు కామన్ అది అసలు అక్కడికల్లా ఆపరేషన్ జరిగింది ఇస్తాను కదా అదే స్వెల్కి మాత్రం తీసుకున్నాను
Try solving it. You have 3 minutes.
తీసుకున్నాను ట్యాబ్లెట్స్ అవే అందుకే ఏమని చెప్పింది ట్యాబ్లెట్స్ ఒకటి పక్కనంటే వీటిని ఆర్డర్ పెట్టాను అసలు వాడు నిజంగా వాడు చెప్పినట్టు నేను డబ్బుల కోసం చేసినానేమో అనుకోయింది. అట్లా ఇట్లా ఊరికంటే రన్నింగ్లో అంతా ఇసులు అవతలి పడుకుంటూ ఇంతలు పడుకుంటా కూర్చోవడం నేనంటే నిజంగానే రాత్రి ఏం పడుకొని చూసాను. రన్నింగ్లో ఏడ కింద పడతామో నాకు కంటికి పడుకోవాలి పెద్ద నేను నైట్ అయితే నిద్ర లేదు. స్వీట్స్ ఇవన్నీ చేసుకున్నాను.
అలాంటి రూమ్ నెంబర్ 316 వస్తుంది. ఏం కాదు పార్టిసిపేట్ చూసుకోండి. వస్తున్నాడు పెట్టింది వస్తున్నాడు. నాకు గిన్నె మారుతున్నాడు. నాకు హిందీ రాదు. తెలుగు రాదు. ఏమైంది ఏముంది రా తెలియలేదు. సాక్షి చూసిందే కంటిలో ఆడకట్టు వేరే ఇది చిల్లర పట్టు కంటి నుంచి ఉంటాయి. మేము వెళ్ళి బిజినెస్ ఉంటుంది అప్పుడు ఇది బిజినెస్లో ఏమైనా ఆలోచిస్తాను. ఏమైంది అనుకున్నాను.
So 183 days.
గ్యాస్ షాప్కి జనరల్గా మీరు చెప్పండి కేక్ తెచ్చుకోబోయాను. పెద్ద కదా తీసుకోబోని కడుగుతాను. తీసుకోమని కట్టింది పెద్దదైతే
Sir 183 days.
क्या आंसर आ रहा है?
183 hours.
183. देखो ऑप्शंस इसके ले लो. B3
मेरा तो बी पार्ट आ रहा है.
B option. C again.
పొందమంటే చెప్పండి. ధన్యవాదాలు. పోటీ నేను కొనుక్కుంటా ఉన్నాడు. కావాలండి బాగున్నాయి. ఎందుకు రద్దు
See how.
అనుకుంటా
The question is of time period, is it not? How many days will be in 1 year? Now 1 year is what? 1 year is time period of Earth. 1 year is time period of Earth. Now what is the time periods? What is the time period? See, Earth is a satellite of Sun, is it not? Earth is a satellite of Sun. Let R is the distance between Sun and Earth's center. Okay, R is the distance. Then the velocity of Earth is of Earth. Earth is a satellite of Sun. So velocity of Earth, orbital velocity of Earth will be under root of gm upon r. I am taking, see, this is Sun. This is Sun. And this is Earth, a very small planet. Okay. Distance between their centers, I am taking it to be small r. Okay. This distance is small r, total distance from here to here. This distance is small r. Means if regarding Earth we have studied that if the distance radius is r and above the surface height is h, then the orbital velocity was this one, gm upon r plus h. So if center to center distance is given already, then there is no need of h height. This will be the height h, but we don't care for height because we have the center to center distance. So velocity equal to gm by r. Now what will be the time period? Time period will be distance upon speed. Distance is what? 2 pi r. Speed is what? Under root of gm by r. So time period is 2 pi r under root of r by gm. Or we can write 2 pi upon, take gm outside, under root gm outside, r to the power 3 pi. This is the time period for any satellite. For any satellite, this you can use as a standard formula. Okay? A standard formula for time period of a satellite. Okay. Now, if r changes to r by 2, means Earth is near to Sun now by half, then what will happen? New time period will be equal to 2 pi by under root of gm into r by 2 to the power 3 pi. Okay, this will be the new time period. Divide both of them. This is 1 and this is, dividing both of them, t by t dash will be equal to 2 pi upon under root of gm divided by 2 pi by under root of gm. Here is r to the power 3 by 2, and here it will be r by 2 to the power 3 pi. So common things will cancel out. R upon r by 2 to the power 3 pi. So this will become r by 2. 2 will go up. T by t dash. T by t dash will be equal to 2 to the power 3 by 2. From here we can write t dash, new time period, is equal to t upon 2 to the power 3 by 2. And what is 2 to the power 3 by 2? Cube of 2 is 2 into 2 into 2. Under root it, 2 into root 2. Total time period of Earth is 365 days. Answer is 365 by 2. This is the answer. Take it down now.
Done, sir.
Done? So time period of satellite, we have seen. What is the time period of a satellite? Okay. Now, is RQ, root of RQ by G. Fine. Now write down the heading. Time period of satellite. See, as we have seen in above question, time period, I am not going to derive it again. Time period of satellite is equal to distance covered upon speed. Distance covered in one revolution divided by its speed. Distance covered in one revolution is 2 pi r. Speed is what? Under root of gm by r. So ultimately we are getting 2 pi under root of r cube by gm or 2 pi by gm root gm r to the power 3 by 2. Okay, this is our answer. Now again same thing. Putting capital G equals to G R by G. Okay, fine. See one thing. Let us make it more easier. We know Gm upon R square. Gm upon R square is what? Gm upon R square is actually a small g. So what we can write here? See, we can write 2 pi under root of R divided by Gm upon R square. Can we write it like this? Yes, we can write it. So it will be 2 pi under root of R by G. If satellite is close to the planet, means not very far, means R is very less than the radius of planet, then we can use this formula. Then time period is what? 2 pi under root of R by G. What is R? Then we can take R, instead of R, we can take the radius only. Instead of this, write down this. R is approximately equal to the radius of planet. Then we can write 2 pi under root of radius divided by G, or 2 pi under root. What is the radius of Earth? 6.4 into 10 raised to 6 meters divided by 9.8. To this the answer is, approximate answer will be 5078 seconds or 84.6 minutes. Means this is the minimum time period for a satellite.
నిన్న ఇచ్చాడు
Let loose. Full ఇచ్చారు. Full
Minimum time period for a satellite if it is flying very close to the surface of Earth, not that much far,
let loose.
10, 20, 50 kilometers.
larger example.
Okay, take it down. I am coming in a minute.
కాఫీ ఎవరికి నాకు పంపిస్తాను ఆ పద్మ లైన్లో ఉన్నా లైన్లో ఉన్నా లైన్ బయలుదేరు బయలుదేరు
we done यहाँ तक समझ में आया? आगे बढ़े. आवाज आ रही है भाई?
हाँ सर.
Now, next is angular momentum of satellite. See, what is angular momentum? We know that angular momentum is momentum multiplied by perpendicular distance, or mv naught multiplied by r. Now what is this v naught? M is mass of satellite. V naught is what? Gm upon r multiplied by r. Multiply that. Take each and everything inside the under root. What we will get? We will get under root of Gm small m square to r. This is angular momentum of a satellite.
Clear sir.
Done? Next. Total energy of a satellite. See, we know that what is the gravitational potential energy. Gravitational potential energy of a satellite. U. What is this? Minus G m1 m2 upon r. Capital M is what? Mass of planet. Small m is what? Mass of satellite. R is what? Distance between center of satellite and planet. And G is universal gravitational constant. So this is the potential energy. But satellite is also moving with a constant speed. And since the speed of satellite V naught, orbital velocity, that is what? Under root of Gm by r. Therefore, kinetic energy of satellite is what? Half m v square, or half G m1 m2 upon r. Under root will disappear. This is the kinetic energy. Therefore, total energy is potential energy plus kinetic energy. This is U plus kinetic energy, and U is what? U is minus G m1 m2 by r. This is equal to, so this plus half G m1 m2 by r. The total answer will be minus by r. This is the total energy of a satellite.
తీసుకున్నాడు 3 వాడినట్టు పోయి రాపా ఒకటి నాకు టమాటా తీసుకొస్తా
समस्या
వద్దులే ఏమన్నా యాడికన్నా పోదామంటే ఆలోచిస్తాను
క్లాస్
యాడికి
అక్కడ తిరగచ్చాను చుట్టుపక్కల తిరిగినా తిరుగుతాం కదా ఏం చేస్తాం ఆర్డర్ దా వరస్ తాగామా
डन यहाँ तक समझ में आया?
हाँ सर.
Okay then, that's all for today.
Okay sir.
ठीक है, यहाँ से अपन लोग नेक्स्ट क्लास में कंटिन्यू करेंगे.
ఎక్కువ అవుతుంది
थैंक यू.